Okay, I have a drawing here, and I want to find the distance between these 2 points. So let's say I connect them, and I want to find out what that distance would be. Okay, got a couple of things that we can do, and this is kind of a cool thing. Alright, each of these is a block, right? So I'm going to simulate that by saying that I have a rectangle that's 1 by 1, so that means it's an isosceles triangle. So this is 45 degrees and this is 45 degrees, which means this is a 45, 45, 90 triangle when these connect like they do here. So there are a couple of different ways that I could find the distance. And the one that makes sense is to do the a squared plus b squared equals c squared. So this is 1 plus 1 is c squared. So that c squared is 2. So c is the square root of 2. Now remember, this is that formula. So if you knew, for example, this was 4, then this out here would be 4 times the square root of 2. Now you can use the Pythagorean theorem and you'll end up with that, but it works that way every time. So if this is 8, this is 8 square root of 2. If it's 5, this is 5 square root of 2. Okay, so that the distance from this point to this point on the diagonal then is the square root of 2. So that's the square root of 2, and that's also the square root of 2. So that's telling me that the distance of that line right there would be 3 square root of 2. Now think about this. If I were to make a big triangle here like this, I have 3 here and 3 here. So then that means that my hypotenuse would just be this number with the square root of 2. So square root of 2, square root of 2, square root of 2 is 3 square root of 2. Okay, now, not only can I do it that way by doing common sense kinds of things, I can also do it using the formula for distance. Okay, the distance formula says that I take and subtract my coordinates, my x coordinates, which would be x2 is 2 minus, this x is -1, so minus a -1 would be a +1. Okay, so then I have 2 plus 1 is 3, so I have 3 squared. Alright, now, my y2 is up here. Now I'm making this be 0.2 and this be 0.1, just like we used to do when we were finding slopes. Okay? So then y is 4 minus the y coordinate here. So this is 4 minus 1 is 3. Alright, so then I have 9 plus 9, which is 18. So I really have the square root of 18. And if I break that down, I have 9 times 2. So that the square root of 9 is 3, so I'm left with 3 square root of 2. But, again, I have my big squares there, and that's why I use this big rectangular grid, the XY coordinate axis with the big squares, because it was easier for you to see that this small triangle then is like a 45, 45, 90, and then I have another one here, which gives me the same thing. So this distance would have been easier just by counting with the blocks, okay? But I can also use that distance formula. Now, What is the distance to the midpoint? Okay, so let's think about this a minute. Alright, the distance to the midpoint, this whole distance is 3 square root of 2. Okay? So if the whole distance is 3 square root of 2, the distance to the midpoint is half of that. Now, you could have said 3 square root of 2 times 1/2. It's the same thing because that means it ends up like this. Now, note that these two 2's do not cancel. They both have to be under the square root sign for them to cancel. So that the distance here is 3 square root of 2 over 2. So now, let's think about what the points would be. Okay? Now, you got to think just a minute. If we're cutting this distance in half, that means we're cutting everything in half. So that means we're going to go over halfway. So if we've got 3 blocks over, we really only need 1.5. So that your x coordinate is going to be 1.5. With 3 blocks up, now your y coordinate's not going to be, well, it's going to, the distance is going to be 1.5. Okay? Now, here's the trick though. In order to get the coordinates of what this point would be right here, I don't have to go over 1.5. I go over 1.5 from here, but it's really only a half. So the x value here would be 1/2. Now the y value, I've got 1 here and then 1.5 to add to it, so that would be 2.5. So the midpoint is 1/2, 2.5. And we just have to do the visual thing and identify because this part is back here in the negative quadrant, okay? And this one is up above the axis. The triangle starts above the axis, so we have to account for the part below the triangle and above the axis. So the distance formula made simple.